POLYUS Scientific and Research Institute was founded in 1962, almost simultaneously with the appearance of the first lasers. Today, the institute, named after its founder, Mitrofan Fedorovich Stelmakh, has become the largest laser center in Russia. It's a state-run leading enterprise in various sectors of laser engineering. Within the last 13 years, the institute has been headed by Director Alexander Apollonovich Kazakov. The basic activities of the institute are development and manufacturing of a variety of semiconductor lasers and transmit-receive modules for fiber optic communications, VOCs, solid-state lasers and various devices produced on their basis, laser gyros, laser medical and industrial equipment, and components of laser systems. Due to its multi-profile activity with top-quality product, POLYUS Scientific and Research Institute has become one of the leaders among the most successful high-tech enterprises. The institute operates in a challenging period of reforms of the Russian market. Currently, the personnel of the institute has over 1,500 scientists, researchers, engineers, high-tech experts, and advanced-level workers. There are 2 academicians, 17 doctors of sciences, and over 100 candidates of sciences. Recently, the institute has expanded its output of functionally complete devices. As a result, it has received a growing number of orders for the domestic market. 1/3 of them is invariably made for the export. Laser equipment is always of great demand worldwide, in the markets of information technologies, weapons, or military systems. The production facilities of POLYUS have unique technologies, which were able to develop and manufacture quantum electronics products. For instance, high-temperature Krashalsky growth of laser and nonlinear crystals, or vapor phase epitaxy of semiconductor structures, or, for example, subsequent technologies to develop semiconductor lasers, advanced technologies for spreading fine film coatings, or vacuum technologies for laser gyroscopy. Thus, the POLYUS Institute is able to manufacture a modern product of new sophisticated technologies and design. The institute is upgrading its production facilities. Equipment is modernized and new production processes are implemented. Thus, we're able to develop competitive devices. The combination of high-tech technology, top professional staff of scientific experts for lasers and laser technologies, unique experience of scientific research and development has made the POLYUS Institute one of the leaders worldwide. With unique scientific potential and excellent production facilities, the POLYUS Institute is able to export its competitive product worldwide. Over a decade ago, the POLYUS Institute debuted at the global market with its product. Subsequently, it started a successful cooperation and expanded partnership with scores of companies in the USA, France, Germany, Austria, Italy, Spain, Sweden, India, China, South Korea, Poland, and Switzerland. Our institute invariably attends international exhibitions and conferences on laser engineering. The POLYUS Institute keeps developing new product and extends marketing research to promote new product for the domestic and global markets. We are able to export over 200 versions of variety of lasers, devices, equipment for different applications, etc., far more exceeding the list of product available on our website. We have scores of hosts every day. Anyone who gets familiarized with our website is introduced to new spheres of applied scientific research, development, and engineering services. For many years, one of the top priorities of the POLYUS Institute has been the development of solid-state neodymium-doped aluminium yttrium garnet lasers and variety of devices based on these lasers. The POLYUS Institute has developed flash lamp pumped pulsed Q-switched laser providing pulse energies from 10 millijoules to 1 joule. We also developed high repetition rate lasers of up to several hundreds of hertz. Both types of lasers are widely used in measuring instruments, rangefinders, altimeters, laser location systems, leaders and in various industrial systems. With nonlinear KTP crystals, we were able to develop the LT series of pulsed frequency doubled laser heads. The pulse repetition rate may reach 500 Hz LT4Z. The energy of a pulse of second harmonic of 200 millijoules is available at a pulse repetition rate up to 40 Hz LT5Z. Our compact LT11 100 millijoules at 1064 nanometers 50 Hz and LT11M 50 millijoules at 532 nanometers 50 Hz. Laser heads with a special design optical resonator provide a laser beam divergence less than 1.5 milliradians and the possibility to focus a beam into a 50 micron spot. They are very effective in various sectors of industry, such as souvenir production lines. A compact LT9 laser at 532 nanometers was operating in remote sensing systems of the Mir space station. It is compact, very efficient and highly reliable. The Institute has developed and manufactured a compact LT8ESM laser with an optical parametric KTP oscillator for eye-safe metrology. The laser provides a pulse energy of 20 millijoules at 1.5 microns and a pulse repetition rate of 20 Hz. The laser head is compact and weighs less than 1.5 kilograms. The Institute has developed compact laser rangefinders with eye-safe KGW active element laser heads. Their self-frequency conversion is based on SRS. They provide a pulse energy up to 10 millijoules at 1.54 microns. Eye-safe laser rangefinders based on solid-state lasers are the most widespread devices. Laser Pribor STC of the Institute has developed a new version of DIM3 and EG-LRF rangefinders which weigh only 1 or 2 kilograms. They operate as light locators with an accuracy of 3 to 5 meters for the range of 10 to 20 kilometers. They are widely employed in topography and geodesy, road building, housing construction, sea or river navigation. The POLYUS Institute manufactured the most efficient expert version EG-LRF eye-safe laser rangefinders at 1500 nanometers. Importantly, the Institute also develops and manufactures modern versions of compact high repetition rate rangefinders for ranging and illumination of targets in laser guidance systems. The POLYUS Institute has high-power CW&D YAG lasers for industrial applications. The RL lasers providing a maximum power of 1.2 kilowatts RL 1200M are used to weld stainless steel parts, to cut steel, aluminium and copper alloys or ceramics. RL20Q diode pumped laser, the RL30Q single mode laser, provides a CW power of 30 watts and in Q-switched operation allows a peak power of 80 kilowatts to be reached at a pulse repetition rate of 1 kHz. Similar output parameters have been reached with diode pumping, the RL20QD laser. The advantages of diode pumping are obvious. There is no need to use liquid cooling. Besides, less heat is emitted due to better matching of absorption spectra of a crystal and diode radiation. The laser beam divergence is also improved, becomes brighter. Thus, the whole system becomes more efficient. For diode-pumped solid-state lasers, the RL05 microchip has been developed to combine active and passive properties. To provide the solid-state laser area, the production of laser rods and nonlinear crystals for solid-state lasers have been established at the POLYUS Institute. Thus, the experts of the institute have found out that the range of crystals has been expanded and their laser characteristics have been improved. Besides aluma-yttrium granite with neodymium and aluma-yttrium with neodymium, the production of GSGG, YSGG, as well as aluma-yttrium granite and aluma-yttrium crystals doped with ermium, golmium, thulium, chrome ions for operation within an eye-safe range of 1.5 to 2.2 microns have been launched. Chrome 4 plus aluma-yttrium granite rods are of special interest. They provide with tunable generation within 1.4 to 1.6 microns. Another laser material developed at the POLYUS Institute to produce tunable generation and mode-locked operation is sapphire doped with titanium. The Institute's modern production facilities are able to grow active and nonlinear crystals for the production of a variety of lasers on an industrial level. From the very beginning, the research and development of semiconductor lasers were among the three top priority guidelines of the Institute activities. The first semiconductor laser was made at the Institute in March 1963. Currently, the technologies of our Institute are able to manufacture semiconductor lasers from A to Z. We grow epitaxial structures including MOCVD to produce quantum well structures with an active layer thickness of 30 to 80 angstroms. We format an element of a specified configuration on the structure. We provide with reflective and protective anti-reflection mirrors, as well as with metallization. We assemble reliable and long-lasting lasers, check and control their parameters. The Institute manufactures laser diodes at 640 to 1550 nanometers, and also the most required for the industry visible laser diodes up to 250 milliwatts. 1 watt IR laser diodes at 810 nanometers to pump solid-state lasers, and 100 milliwatt single-mode laser diodes at 920 to 980 nanometers to pump fiber lasers. The Institute has developed the technology for the lasers utilized for the production of DVD players and started their manufacturing. The further increase in power and pump energy can be obtained if emitters consist of dozens or thousands of diodes in a linear array. The output power of a 10 mm linear array is a quasi-continuous operation, achieves 150 watts at 808 nanometers. 5 linear arrays mounted on a heat sink submount are the base module for the assembly of stacks of various configurations. The average power of a base module pulse reaches 600 watts within spectral range of 808 to 812 nanometers and 940 to 980 nanometers. The development of long-lasting emitters opened the road for transmit and receive modules for FOCs, local and toll lines, cable TV. The POM14, POM17 transmit modules at 1.3 microns and the POM18 module at 1.55 microns for a data rate of 560 megabit per second, and the POM19 and POM19-1 high-frequency laser modules with a modulation frequency band up to 10 GHz. These modules are widely used in Russia or manufactured for the export. The POLYUS Institute has developed the POM21, POM22, POM23 fiber Bragg grating transmit modules with a line width less than 500 kHz at 1060, 13010 and 15050 nanometers. For trunk fiber lines, a semiconductor optical amplifier with a fiber-fiber amplification of 10 decibels has been developed. Laser gyros are absolutely unique, and they are used where their complete features are used. They move and stop immediately. They're powerful and resistant to all mechanical or climatic effects. They have a high potentiality and lower cost if compared to other devices with similar weight and overall dimensions. The high accuracy KM111A laser gyros with linear polarization, a prism resonator and high frequency discharge excitation have been developed for civil aviation and other civil devices. Compact laser gyros with circular polarization, magneto-optical dither and DC discharge show an accuracy of 1 degree per hour to 0.1 degree per hour. They have been developed for the navigation and now manufactured. These gyros are used for highly dynamic measuring and control systems. For instance, the gyros operate in the devices to examine the profile of railroads, motor roads, in inclinometers, as well as the systems to examine gas or oil pipelines. The production of laser gyros requires a very special, high-quality equipment based on original designs and domestic technologies. One of the most important types of production of the POLYUS Institute are germanium hybrid integral photoreceiver modules. We have developed and now manufacture several versions of photoreceiver modules based on avalanche and PIN photodiodes operating both at a conventional wavelength 1.06 microns and in a promising eye-safe spectral range of 1.54 to 1.57 microns. Miniature two-channel photoreceiver modules operate in the visible and near IR spectral regions. They are designed to be used in ring laser gyros for multiple purposes. Currently, the Institute has started a new promising sphere of science and technology: the development of fiber optic data acquisition and transmission systems for aviation and space technology, seagoing vessels, and a variety of industrial products. The POLYUS Institute manufactures germanium avalanche photodiodes of the LFD series 11 modifications, the FMP photoreceiver modules for FOCs 6 modifications, the FPUD receive modules for laser ranging 12 modifications, which are extremely sensitive and have fast response. High-speed indium-gallium arsenide, indium-phosphide PIN photoreceiver modules at 1.3 and 1.55 microns for analog and digital fiber optic communications have been developed. Wideband microwave indium-gallium arsenide PIN photoreceiver modules have been developed for direct conversion of optical picosecond pulses and optical signals with high-frequency modulation up to 12 GHz into an electrical output signal. The POLYUS Institute is one of the leaders in Russia to develop the manufacture high-tech systems for surgery and ophthalmology for many domestic clinics. Now we plan to develop new laser equipment, more compact with new wavelengths, for cardiology and physiotherapy, urology, oncology, physiology, surgery, dermatology, ophthalmology. According to the ISTC project, a new laser complex for diagnosis of oncology diseases at early stages has been developed. We have also developed and tested in our institute the module GF device, which combines the method of hyperthermia and photodynamic therapy to treat oncology diseases. To fight urology diseases, the Urilo-Synchro device produced at the institute is now used. The optimum ophthalmologic system has been manufactured for eye microsurgery. For laser therapy, the ALTP series and the Matrix device based on semiconductor lasers and LEDs are available. Being a high-precision and high-speed tool providing ecologically clean production, lasers give fundamentally new opportunities for industrial equipment, including machine building, metalworking, tool mechanics, radio electronics or printing industry. The unique quality of laser technology is the possibility to do something that cannot be materialized with common means, or to provide it on a high-tech level. The POLYUS Institute has developed the Quant series series of industrial systems that are widely implemented in the Russian industry. The computer-controlled Quant-60 laser marking system allows high-speed laser marking for practically all solid materials. The system can mark a wide range of electronic and machine-building products. Quant 155 compact laser welding system has been made for precision, high-quality welding of practically all metal-compatible materials and alloys, including high-conductivity materials, silver, gold, as well as refractory materials, molybdenum, tungsten. The system can be used in electronic industry, machine building, dentistry, or jewelry. The Institute has developed the Journalist Mobile Automatic Printing Center, which uses the laser plate device to make offset plates. The center promptly makes the print run of newspapers, booklets, and other print production. To make souvenirs, for example 3-dimensional pictures in glass, the laser art system has been manufactured and exported worldwide. LPS wireless laser links are available to provide transmission of E1, E2, E3, Ethernet 10 and fast Ethernet via digital information flow, simplex or duplex communication between objects within the line of sight distance of 1 to 2 kilometers. The Institute has developed a special compact reliable Kelvin infrared thermometer for non-contact rapid measurements of temperature, of power, equipment, industrial furnaces and heating systems, electric cables, steam, gas and oil pipelines, rolled steel, heat insulation, etc. The temperature options are from 30 to 1800 degrees centigrade. A modification of the device can be also used to take body temperature without contacting the patient. The new Criminalist compact device has been designed to detect fingerprints, even the old ones, microparticles, microfibers, blood vessels and chemically etched stamps. The POLYUS Institute has developed 2 versions AOS-3S acousto-optical spectrophotometer based on turnable acousto-optical filters to measure the characteristics of optical coatings both in finished products, the AOS-3SL desktop version, and in systems in the process of vacuum deposition. The POLYUS Institute offers competitive, wide-range, high-quality and reasonably low-price product. It provides equipment and devices in Russia and worldwide.